What's up guys, how's it going? How are you, boy? I'm Mario Roller, physics teacher. I'm here today to review the subject of statics with you. Oh, static is part of dynamics. The static guys study rest. But what would that be? Very simple, oh. First note there with me, go. So guys, it's the part of physics that studies balance, resting still. But Mario, what do you mean? Does it necessarily have to be stopped? No. Necessarily the resulting forces must be equal to zero. But you have two cases of kinematics where this happens. This can happen, folks, in uniform rectilinear movement, but it can also happen where, folks? In your own rest. So get in touch, come here with me. Resultant force equal to zero, acceleration equal to zero. But Mario, what do you mean? Dude, imagine there's a force FTWO here, a force phone here, a force F3 here, a force 4. Dude, imagine the following, look, phone, if it is equal to FTWO and F3 equal to 4, that means that these total forces, its summation is giving 0. So that's it folks, that's balance, that's what static is. It's when the sum of all forces are 0, it's when all forces are 0. Come here with me, oh. This means the following, look. The sum of all resulting forces is 0, that is, everything on one side is the same as the other. But I'm not going to lie to you, right guys? Generally, people have a certain difficulty with mathematics, so come with me so you can understand. First, let's see here what the balance of the material point is. Look how simple it is. This system has balance. Let's put some dough here just so we can work better. 40 kilos. All good? Look what an interesting thing. Look how easy it is. This point here is the material point. This is the point where there is balance. So it means that all the forces acting at that point are 0. All the forces that are acting at this point, people, if you add them up, it will come to 0. So let's put our strength in first, guys. Look how easy it is, oh. This force that is hanging here, pointing downwards, is called weight. If I have thread, I have traction. If the thread is the same, the tension is the same. Oh, to keep it organized, I'm going to call this one wire 1 and this one wire 2. Here I will have the traction of 1, folks. Here I will have the traction of 2. Now is when the party begins. It is now that we will learn how to resolve this here. Let's take it easy. Let's go in the morning. Here's a video. You'll come back with anything. Pay close attention. First step, put in all your strength. My goal is to know what is traction value 1 and what is traction value 2. First, put something in your head in physics. There is nothing crooked or horizontal or vertical. Come here with me. Come here. Come here in physics. There is nothing crooked, inclined or horizontal or vertical. So come here with me. This traction can. Can this tone? It can't. Can this T2? You can't. So come here with me for this one to be stationary, for this one to be in balance. This force that points upwards is the same as this force that points downwards. How do you calculate, guys? Weight is mass times gravity. The attraction is the same. Who is this guy's mass? It's 40. Who is gravity? It's 10. Response? 40 newtons. All good. Now what am I going to do? I analyze this guy. I want to analyze this point. Do you do X like this to us? Just to help you think better, okay? Come on with me. T2 cannot, so you will get its shadow at X, which is TD walks, and you get its shadow here, which is T2. What guys? Why? I'm going to do the same thing with the other one. You're going to take your tone X, which is towards here, right? Tone X and up here T2Y. Can you see? Tone XY. Sorry, do you see? It's a little messy, a little strange. So I'm going to rewrite it here just to help you see it better. Oh, I have a strength here. Who was it? Tone. This tone is gone, guys. D no longer exists. This tone became two forces. It turned one upward, which is tone E, and it turned one to the left here, which is tone X. Beauty? This guy there, look, T2 also ceased to exist and now he's here, folks, with this T2X force, and he has a strong force, my old man. Who is that? T2Y, is everything okay? Beauty? And there's this guy down there who is this attraction. Oh, this attraction that is T. The problem is this, old man, you have to know how to calculate who is Ty, who is T2Y, who is T1X, who is T2X. Take it easy, the issue is practically resolved. Remember balance? Everything up is the same as down. Everything that is to one side is the same to the other. In other words, right? The one pushing to the left is tone X. The one pushing to the right is TDWOX. So it's the same as anyone else. Those who are pushing it up are these Y here. It's this attraction that's pushing you down. So let's get the party started. Let's do the short ones, okay?
Oh, tone X is equal to TDWOX.
2x.
Because whoever pushes there has to be the same as whoever pushes here. You have to be in balance. Come here, who is tone now? This is where I want you to be very careful with this angle, right people? It is being formed with the horizontal. So he's here with this horizontal. So if here is 30, this little piece here, it is 30. If here is 60, this little piece here is 60. So, come on with me. This X, it has this angle. If it is with, it is cosine. If it is without, it is the sine. So, there's this guy. You will take its reference traction, which is tone, times. Come on, he's got an angle. So, it's the cosine of 30. T2 would be who? It would be the angle, the reference vector, which is T2, and it has this angle of 60. So it's the cosine of 60 degrees. So now we just have to resolve it. Look. Tone times. Who is the cosine of 30 degrees? It's root 3 over 2. TTWO is equal, go. This guy here, folks, the half cosine is 1 over 2. I have 2 on one side and 2 on the other. I can cut them. So I know that TTWO is equivalent to tone times root 3. This here is a function, an equation. Never mind. Let's now do a vertical analysis. What do I know about vertical? I know that up is tone plus TTWOY.
Y.
That point up. Down is the attraction. How do you calculate tone? Who is his reference vector? It's tone. As it is here in Y, it has no angle, so whose sine, folks? Sine of 30 degrees. But, come on, who is TTWOY? You take its reference angle, which is TTWO times the sine referring to it, which would be who in this case 60 degrees is equal to the attraction that we have already calculated. How much does it measure? Measures 40. Do you see how easy it is? Come with me. I don't know what T2 is worth. I'm going to take this T2 here. I'm going to put it in here, so it will look like this. Tone times sine of 30 is 1 over 2. But who is T2? T2 is worth tone root of 3. I took it and put it here, because T2 is worth that. Go, times, who is the sine of 30? It's root 3 over 2, times 40 of 60 degrees. I messed up. Come on. These two are dividing. They would pass to the other side by multiplying. So I have to tone plus tone times root of 3 of the root of 9, which gives 3 is equal. Remember these two. He can go ahead and multiply, then turn around and try go here. It gives 4 is equal to 80. Tone gives 80 divided by 4. Tone gives 20 newtons. If I know who tone is, I can easily find people who are T2. Because T2 is tone root of 3. So T2 is equal to tone root 3. Who is tone, people? It is worth 20 roots of 3n. We have just calculated the value of tension, which is 40n. The value of tone is 20n and T2 is 20 root of 3. There you go. Take your print. Do you see how simple it is? See how easy it is? Guys, I hope I helped you, okay? I'll give you more tips later. I'm going to try to record videos every week now, okay? The Enum is coming, my first year group. Here's a tip for the test, you know? All the best. If you like the class, collaborate with the channel, boy, will you? For us to shake up this studio here, hey, it's still echoing, okay? My pics, okay? It's mariofizz.com.br, collaborate there, help there. All the best, see me my people. Bye, thank you very much.